who have come now, and to Peter, who is our presentator now. The theme is why proper logging is important in all phases of development. Much fun.
Thanks. I will talk about logging and about syslog-ng. I'm Peter Czanik from Hungary, community manager at Balbit. Syslog-ng is upstream developer. Balbit is an IT security company headquartered in Budapest, Hungary, with over 100 developers running Linux. I'm also not really active part of the OpenSUSE testing team, and I'm the syslog-ng package maintainer for OpenSUSE, and also work sometimes when I have a bit free time on the PowerPC and ARM boards. So first of all, let me state that this presentation isn't about cutting trees, even if it's about logging. So what is syslog? I will address quite a few questions about logging, about free-form messages and name-value pairs. And I cannot avoid talking about the journal, and I would like some standardization efforts like CEE and Lumberjack, and at the end I would like to demo the use of name-value pairs using ELSA, which is a quite new and impressive logging software. So, first of all, what is syslog? It's logging, it's a recording of events on a computer, and syslog can refer to many things. It's an application which collects the events. It can also refer to the data, the actual log messages, and it's also a protocol, and the forwarding of these events over the wire. It has a pretty long history from the beginning of the 1980s, as it was originally developed as part of Sendmail, but it was quickly adopted for many other uses. Syslog-ng, the name, the ng refers to next generation. It's a next generation syslog server developed as an open source project since 1997, and it has a very strong focus on central log collection. It's often referred to as a Swiss Army knife of logging, as it can do quite a lot of things. I mentioned that it was originally an open source development. A few years ago, Balbit was approached that a couple of companies couldn't use syslog-ng without being able to pay for it, to be able to buy enterprise level support. So that's why we also have a separate paying edition. But in this presentation, I will always refer to the open source edition, which isn't really much different. So why is it next generation? It has a lot higher performance than the original syslog-d. It has a lot more input sources, destinations, and it has a lot better filtering, and it has many processing possibilities, like rewriting the message, parsing it, correlating log messages, and so on. Recently, I mentioned that there are some standardization efforts, and JSON was chosen as a method of forwarding log messages, so we have no JSON output and JSON parser for syslog-ng. And just last week, AMQP destination was added from a third-party developer. So who uses syslog-ng? Syslog-ng is the default logging solution in SUSE Linux Enterprise Server for almost 6 years now, but it uses quite an old version. It's also the default logging version in Gen 2, and it's also available in OpenSUSE, where I'm the package maintainer. And where else? What do you think where syslog-ng is used mostly, and which version? Any ideas? Ta-da-dum! Kindle. Over 40 million devices are running syslog-ng, but it's an ancient version which is quite popular still in embedded devices. It's 1.6, and we are we are working now on 3.4. So it's over 10 years old, but it's still running over 40 million devices. And NASA is one of our biggest user with over 40,000 machines running syslog-ng. And we just learned about a month ago that many of the Cisco security appliances are also running the syslog-ng open source edition. So the next big question is what to log. It would be easy to say that everything, but that's clearly not possible due to resource problems, as simple logging would take all CPU and I/O. So there are many checklists what to log. And the most well-known is the Sense top 5 log reports, which describes that you should have these items like authentication, change, resource access, and many others listed on pages what to log. The problem is that even if we have all these nice resources, logging is often an afterthought in development. So once something is developed, at the end, oh, we need logging. But so many of the above points are missing. That's why the title is that why we need to care about logging in all phases of development. As even if there is some logging in software, it's often just for the developer helping to debug broken code. But that's not enough in a production environment to audit or debug a problem in production. That's why we always try to emphasize that logging should be an integral part of software development, and during the development of software, one should always think about the production environment. Recently, there is a new movement called DevOps, people with both a developer and an operator hat, and it's always good to have these kind of people in software development teams who know what to log. And another important thing is that one should use a similar logging environment during development as in production. Other way, we end up with log files generated directly by the application and stored in 10 or 20 different directories and hundreds of small little files. which probably help the developer, but a nightmare in production environment. So, how should we log? There is a short answer: centrally, but there are many reasons for it. First of all, ease of use. Just think about that you have 20 machines and you need to find where something happened. Then you don't have to log into, oh, we have these 5 web servers, then I check for this. If it's not happened there, then we have the next. But if there is a central log server, then there is a single source of log messages, and it's easy to grab or search by any other means. Another reason is availability, as even if the sender machine is down, there was a crash or any other problem, logs are there, and it's easy to debug the problem. You don't have to wait for a file system check just to see why the machine went down, but the logs are there and easy to check. And last but not least, it's security. As the logs are stored securely at a central location, even if the sender machine is compromised, and logs are deleted from the local machine. So one can find the traces of the breach in the logs in the central location. Next, I would like to talk about the actual log messages. If you look at var log messages, where most of the logs are stored, you will see that the general form is a date, a host name, and some text. Here is a log message from SSHD. You will see that it's practically an English sentence with some variable parts in it, like the authentication method or IP address or port. It's quite easy to read for us, but as we will see, it's not really easy if we want to do anything with these logs. As on a server, there are a lot more log messages, and also there are a lot of applications logging, and with these properly formed English sentences in log messages, it's easy to read for us, but to find relevant information or prepare a report by a script, it's easy to become a nightmare. Just think about that source IP address or destination IP address. An IP address could be even the sender host name, sender host of a message, or source IP or destination IP of an action. There is a answer for this chaos. It's called structured logging, which means that events are represented with name value pairs instead of using free-form text, which is probably a bit more difficult to read for us, but as long as we have to prepare a report or search relevant information from a larger number of log messages, it's a lot more easy to use. syslog-ng had name value pairs inside from the beginning, as it used the date, the facility, priority, and other syslog parameters as name value pairs to help filtering or message storage. So the name value pairs were already long available for syslog-ng, and recently, so about 4 years ago, pattern DB was introduced to syslog-ng. It's a message parsing technology which can extract useful information from text messages into name value pairs. And it can do many other things like adding status fields to log messages, or do some message classification, like taking an SSHD login failure as an example. User equals root, action is login, status is failure, and it is classified as a violation. But it's quite flexible how we use it. Next, I would like to talk about a new buzzword. It's called the journal. It's the login component of systemd, which is used now by default also by OpenSUSE and a couple of other distributions. It was built on name-value pairs also from the beginning. Just in syslog-ng, the message is just one of the many name-value pairs. It has also trusted properties, as the journal can extract information from the process file system about the central process. So even if an application can fake information like the process name or PID, systemd can still extract the real information from the process file system and store it next to the message. And the journal was planned with name value pairs from the beginning, so one can store any name value pairs also. And it has a native support for storing everything in binary format, which supports name value pairs. The journal can easily work together with any other syslog implementations, including syslog-ng. The persistent log storage of the journal can be disabled, so there is no double storage of log messages, and the logs can be forwarded to syslog-ng through using a sockage, and syslog-ng can filter process logs and forward them to a central log server just as before. But we have the added value that the journal can catch all of the early boot messages, while with syslog it's quite difficult to catch the early boot messages, if at all. So I often get the question if journal is the enemy of syslog-ng. And there is a quite short answer: no, it isn't. Why I can say that? First of all, the journal is local only. There are some plans that it will have some networking support, but it is still far away. Syslog-ng was built as a client-server application from the beginning. The journal doesn't filter or process log messages at all, but stores everything what it receives. Syslog-ng can do many different filtering, processing, as I explained. And the journal is limited to systemd, while syslog-ng can run on all the different Linux distributions, BSD, and many of the commercial Unix variants. Here are just a few. The journal, syslog-ng, Windows event log, rsyslog, audit day, and many other logging solutions are based partly on name value pairs, but there is a huge problem. All of these use different field names and different fields, so they can't really interoperate easily. So standardization is a must. Now there is a new, well, not really know, about 5 years old standardization effort. It's called CEE, or Common Event Expression. where I'm in the working group. It was initiated by the US government, and many commercial vendors and free software developers are participating. It stores events as name value pairs instead of free-form text, and tries to standardize log transport and also how logs are described. So there is a dictionary which are name value pairs describing event parameters like usernames or source or destination IP addresses and so on. And there is a taxonomy describing what is the actual log message, like it's a login event and so on. And the good news is that PatternDB can be used to turn free-form text messages into these CEE messages. At the end, I would like to talk about ELSA, which is not a girl, but an interesting new development called Enterprise Search and Archive. It's based on syslog-ng and PatternDB and stores messages in MySQL and uses strings for indexing these messages. ELSA itself is written in Perl and has a simple but quite powerful user interface. It has extreme speed and scalability. So I've seen that 40 terabytes of logs could be searched with Google like response time. So searching all of these logs under 1 second, which is quite an impressive speed. It has a strong focus on networking security. It's developed in a networking security and response center of a university. So it has many bundled patterns, and for firewalls like Cisco, IP tables, and so on, for many different intrusion detection systems like Snort, Suricata, Bro, for many different HTTP-related logs, for Windows logs, and so on. The interface looks quite simple, but here we already can see that with bold letters we can see the original log message, and below it we can see the name value pairs parsed from this message, like application, snort ID, source IP, destination, and so on. It has many other. Oh, and I'm not sure how much it can be seen, but here in the command line, here is also a filter. So the results are filtered through a whois filter. So any IP addresses are resolved. So one can see where a particular network traffic is coming from in the log browsing module. One can also do nice graphs, like the distribution of attacks detected by Snort, or the source of attacks on a map. Finally, I would like to summarize why I find syslog-ng important. First of all, it's over 15 years of open source development, high performance log management. It has a very a bit difficult to learn, but on the other hand, very flexible configuration format. Very good. It's very well documented, and there is this PatternDB message parsing, which can do magic with the log messages. So, any questions?
A question. how can you filter the right logging messages? You have written down host and date, but you need the time too, and that's very much